Hey, what's going on, guys? Makikins here. In this video we're going to be implementing perf test function. So just like it was already mentioned before in the previous part, the idea of doing this is just to specify the number of nodes being traversed within every single root move within our move list. So if any bugs are about to occur, we can we can track them easier compared to if we don't have those number of nodes per root move. So if we just compare the results with some working move generator, and we see like that the number within this root moves traverse nodes is different, we know that this exact particular move is causing some sort of a bug, and that's how we can track it basically. Anyway, without further ado, let's actually go for some implementation. But first, I just want to run the compile and run the code. So I just say make. Well, let's go for make debug for now because we're not running anything yet. And then I'll get back to just the simple make to provide the optimized version of the mode generator of the entire chess engine. So if we compile and run the BBC binary executable, and it should be running perf test from the previous part, which we don't really want now at the moment. And so let's have a look. Okay, so just right below this perf driver, I would like to create the perf test, and I guess we don't really need to call it static inline because it's going to be called only once, and then this perf test would be calling the perf driver recursively. So we can simply say like perf. By the way, for those of you who don't know what does perf means, this means performance. So perf it stands for performance test. Okay, so perf test, and here we just create the void perf test function, and it would only be taking the depth, the search depth. Okay, so we also need to create the move list and loop over all of these moves just like we do within our perf driver. So let's actually go for it. Also, let's just print. Well, it doesn't require any commentary. So let's say printf, and let's call it performance test, like this. Okay. And here, we would be calling our perf driver, right? And after taking back, I would like to print the move. So we would be using our print move macro here. So print move, and I'm passing this move right over in here. I just get rid of this perf driver call, just to make sure the moves are printed correctly and all the stuff like that. So let's have a look. I just want to make the layout nice as well. Okay, so we don't need this part, and it's actually a good idea to call the perf test function. So let's have a look. Okay, so it prints the available moves. Good. Okay, I'm just wondering. Probably. I would probably need to duplicate the code to just to give it a space, or can I somehow? If I just try to print some spaces before, just want to prettify the layout, that's it. Okay, so it works. Okay, so I can simply say like move, and this would be the move after the move, well, another issue that it actually prints the new line after. Well, I don't really, well, okay, so let's go to print move macro. I just duplicate the code and change this slide a little bit. This would be just an easier way of doing things. So let's print this like this, but I just want to print like move here, and also the number of nodes that has been traversed within the given root move. So let's call it nodes like this, and this would be the long decimal. Yeah, I think this should work. So I'll now provide the logic of calculating those nodes, obviously, but first let me deal with the layout. So print results. Okay, let's have a look again. Oh, what? Yeah, it's not the move, it's this one. Okay, so it doesn't take anything here yet. Okay, so the layout, probably I would give one more space. Yeah, now this is good. Okay, now I like this. And at the very end, I just want to print some summary. So the depth would be I'm taking the depth, right? Okay. I'll get rid of that warning. Just right in the moment. So okay, it's a little bit too much. So we got the depth. Okay, and now I want to print the nodes. So nodes and nodes here, and also print f the time. And is this gonna be long decimal? Yeah, probably. And I didn't yet calculate this. So before we start a loop over our moves, we need to initialize start time. So integer, or is this the integer? Yeah, integer. It's not. Why do I consider this to be long decimal? Or hold on a sec. Well, let me try this. I just don't remember. So int start equals to get time in milliseconds, and here I just want to say get time in milliseconds minus start. So is this? Yeah, it gives me another warning here. Okay. So I can either go for. Is this enough? Okay, so let's make it actually long. Yeah, let's make it long. And this would be the long decimal as well. Okay, what's wrong now? Come on. Oh, nodes is still wrong. So obviously, yeah, nodes long decimal as well. Yeah, and this warning is just we'll just take care of it just right in a moment. Okay, I don't really want to have this new lines. And I want to print one more new line after time. Okay, yeah, now this looks like quite pretty nicely. And probably just to make it the same as move, can I just, yeah, no, this is absolutely perfect. Okay, so now we need to define the variable called cumulative nodes. I really hope I did spell this this word correctly. Cumulative. I'm not sure how exactly to pronounce that. So this would be the long type, and it would be equal to nodes, and also we need to define old nodes, right? Yeah, old nodes, and long old nodes would be equal to nodes minus cumulative nodes. And this old nodes is exactly this is the exact number of nodes that we need. Oh, sorry, what have I done? So that we need to print right over in here. So old nodes like this. So now it shouldn't be given any errors. Okay, and if I did everything correctly, this should now start working. So let's start with the perf the depth 1, and also, well, let's go for start position first, and then we'll go for test and tricky position. We have already done that before, but just to show you this new features on the perf test function. So we printed the nodes reversed within the root node, and as far as we will start increasing the number of the increase in the depth, we see like this cumulative nodes, this old nodes kind of getting increased. So let's go depth 3, and let's also make sure that we have the correct numbers. So it should be 8902 or 8902. So exactly what we have here, and already the number of this old nodes is getting different. So the idea is, if say you don't have this 8902 but have some different value, that means that something horrible has wrong within your node generator and you have a bug somewhere, and then you just can compare your results with this like table, say taken from this engine or from whatever engine that you're sure that you trust it kind of works well. Well, at least you need to make sure that it gives the right number of nodes. And then you can just go move by move, so starting from move 1, move 2, and so on, and just comparing the results from the working perf test, and from the engine with a working perf test with no bug-free one, with your own results. So you just imagine like, I don't know, I just want to duplicate this. I just want to duplicate this. Oh, it's not here. Just want to make a new window, and can I make compile? Oh, it's not that. So let's say make debug and BBC. Okay. So let's imagine that window on the left is the working one, is the working version, and this one is your current version. So if this number is not the same here for some reason, that means that you have a bug. So in order to track that, it's incredibly handy to find a move that is actually producing that sort of a bug, and that narrows the scope of where to search for possible bugs occurring. So let's say you compare it, okay, this 380, 380, 420, 420, okay, and say somewhere over in here, you say like instead of 400s, you will have 405, let's say like that. And you know, then you will know that this exact move is actually causing a bug, and that's the way, and that's the reason to search what's kind of wrong with this move. So just to give you an idea of where exactly to search for the bug within your move generator, because otherwise you can only be guessing, and that's that's incredibly painful, to be honest. Okay, so let's continue our test. So also prints, but hold on a sec, I'm just wondering, something is wrong with the time. I'm not sure why the time is, or it just takes too little time. Well, we'll see now. Okay, so let's try the depth 4. Okay, let's try the depth 4. Yeah, time is fine. So 197281, and this is the exact number we supposed to be getting here. And actually starting from, well, we can still go for depth 5 without this optimization flags, but it takes up to 2 seconds. So yeah, already if it just turn on our optimizations, it would be going really faster. So we have this 4 millions 865609, 4 millions 865609, exactly the same number. So I just want to demonstrate you this. So we just get rid of this debug, and again, like assuming the make file that I'm using in particular, this one. So I'm using this -o fast flag to compile the source code. Make sure you're using this flag as well if you want to get the same results as those been shown here. So if I now run this again, it takes longer to compile, like already was mentioned. By the way, I'm doing the Windows version simultaneously as well. But now it takes for about twice faster, even slightly more than twice faster. So it was kind of 2 seconds and a half, and here it's less than a second. So it's quite pretty nice result. And you see like the old nodes are getting really big values already. Okay, so the very last thing here, well, not the last yet. I just want to show you this. First, yeah, I just want to show you this with a depth of 6. So remember, like the last video, we've been waiting, watching the white void on the screen without an idea whether it works or not and how long does it take. But here we can already see that our moves are getting traversed on and on, and that's kind of it. So, and yeah, we have this number, or hold on a sec, yeah, so yeah, it's already depth 6. Okay, 119.060.324. Let's compare, and this is it. Okay, so this is the number. Okay, so if you have time, you can play around with depth 7 and 8. It obviously takes time to complete, but just in order to make sure that these numbers are actually are get correctly. Okay, so now I just want to switch to the tricky position and show you this exact steps again. Tricky position, and well, let's go for, well, we can actually go for the depth of 6 straight away. It would take for about 30 seconds to complete on depth 6, but yeah, that's just fine. It's about from 8 to 7 seconds and the depth of 5, and should be for about 30 or maybe even 20 seconds. So we'll see. So it goes move by move, and there would be up to 48 moves. Yeah, well, okay, probably it would take too long. So yeah, it would take too long. So let me just drop back to 5. yeah, because that's kind of too long. Let's have a look at the depth of 5, and then we'll try to run this on Windows on Wine Emulator to running the Windows binary executable to make sure that it's still working as expected on Windows as well. So yeah, we already did this test in the previous part, but without printing this old notes corresponding to every single given move here. Okay. Okay. I'm still a bit confused about the time. Did I do something wrong again? I just don't remember what depth I've been testing this in the previous part. Oh man. So I remember I did check the make file. Okay, let's try again. Make and BBC. It seems like it was running without the optimization flags again. Or what? I'm not really sure. Well, anyway, we need to test this on Windows now, with the Windows binary executables. Oh, that was the depth 6 on the initial position. Yeah, we didn't test this one. This one without the optimization flags would take for about a minute or even longer. So yeah, this result is just fine. Yeah, I just forgot we were dealing with the third position at the depth of 6. Yeah. So the very last thing to consider, this 193.690.690 is exactly the same number of nodes traversed at the depth of 5 here. So just to compare these numbers, have a look. So 193.690.690. So this is the number, the exact number of nodes traversed that we need. Okay, guys. So I will now run this on my Wine emulator, but before that, probably let me find a proper place for this perf test code. So I just want to grab this like header, and just right after the move generator, say here, I will provide a new section called PERFT, simply PERFT, like this, and this would be exactly the place to put our PERFT related code to. So I just cut it from here, save, and paste. Okay, save. Yeah, now should be working literally the same. I just want to add this get character to avoid window disappearing on my Wine emulator. So let's run this again. And obviously, if you guys have a faster computer, a better processor compared to what I have, this should be running faster on your side. Well, obviously, assuming all the optimizations provided by -o fast flag. Yeah, so it's working. Well, I really hope that the number of nodes didn't change after this, after putting the code in a little bit different place. Okay, so the very last thing to consider, just want to view the folder, and let me try to run this via Wine emulator. So yeah, it would probably a little bit well, also I'm a bit wondering what the hell does this symbol stands for. It's not really that clear for me. well, I could actually get rid of that, of printing this, I mean like promoted piece. So if promoted piece is equal to 0, it prints nothing on Linux, but it does print something on Windows. Yeah, so the time is slightly longer because this is the emulator, obviously it's not a native execution. And yeah, so the number of nodes is correct, everything is correct. Yeah, so the only problem here is the move itself. I'm just really wondering, well, if I just get rid of that, so probably, yeah, it needs, I really need to think a little bit how to fix this. Okay, guys, just hold on a sec. I want to reference one of my old codes to make sure how to make it working properly. Well, okay, so it's just a matter of testing whether the promoted piece is available. So I can probably say here, like, let's try to take this get move promoted, copy, and paste. So if it returns true, I would be printing just, I would be printing this piece. Otherwise, let's just print an empty character. So this should now fix this issue. I'm not really sure though how is this gonna be working when it comes to the UCI protocol. So is that extra space gonna be a problem? Well, sorry, I don't really want to run this here. So I'm not really sure if that extra space is gonna be a problem within the UCI protocol. So I would research that, obviously. Just didn't prepare this, at least for this video. I wasn't expecting that, so just at least I want to make sure that it doesn't print those nasty characters after remove. Okay, now it doesn't print those nasty characters, but still we got a problem within the print move itself. And okay, so until it works, let me just, again, I just want to reference one of my previous codes. So so I was checking like if promoted, but okay, here, so without a promoted, so I was just printing different, I was just printing some different, I just wasn't printing it. Yeah, okay, so well, let's actually go and alter our print move, because yeah, otherwise it might turn a disaster. So let's say if hold on a sec, is this the same for both Windows and Linux? Okay, let's say if print move, yeah, if this expression equals to true, then we can just print our move, and else I just want to print this, but without this part. So just to make sure it would be working exactly the same on both operating systems, like this. So save, and one last task before I finish this video. Let me just I will leave this part when I finish, but first I just want to, let's print print move, and let's get character as well. So make sure this works on Windows as well. So just print move, and let's encode move. Let's say E7, E8, queen in, and okay, so this would be the pawn, and it's queening and no flags like this. So just want to make sure. Okay, I don't really, now I don't need this. Yeah, so it prints. Okay, and if I don't have a piece, and let's say E2, E4, it should now be printing without, but there shouldn't be any empty space after. Yeah, well, I can check that basically, but assuming the implementation, there shouldn't be any. And well, I can actually print two moves. So this one and E7, E8, pawn, and queen in. Okay, so one last test here, and also okay, and also I just want to make sure it works the same on Windows. So yeah, works absolutely the same. Well, perfect. So just one last glance to my print move function. Okay, so printing the character, and otherwise just not printing. Okay. Well, probably it would be working even without these complications, but as far as printing move doesn't affect the performance, we can allow this little branching here. Okay, so now I'll get rid of this code because we don't really need this anymore, and just to leave you the executables for you to be able to run them. Just want to compile them with optimization flags one last time. Okay, so now it should be working nicely. So, well, okay guys, so anyway, this is it from my side. I'm sorry for this little debugging at the very end. I hope the idea behind perf testing is now quite pretty clear for you. I hope you've learned something interesting out of following this tutorial regarding perf test, and starting from the next videos we would probably go for implementing, yeah, perfect, we would probably go for implementing some very basic UCI interaction between the chess engine and the GUI, and the reason for doing that is actually to be able to debug our search already within the GUI, because otherwise it would be taking time to write those drivers to test this test the search. And I really like to see visually like how chess engine starts playing versus itself, and how it improves its play when you're changing something. That's really interesting to watch basically. Okay, so now this is really it from my side, and I really hope to see you in the next videos, because starting from now we're coming, well, so we've just ended the biggest milestone within whatever chess engine. Passing the perf test is considered to be the biggest milestone. So starting from this moment, later on we would be actually making our chess engine playing chess, and that's gonna be exciting. Okay guys, so until the next time, and take care.